In sheet initial stress, all parameters required for Kirchhoff's formula have to be specified in this input form. That is, the tunnel radius A, let's say 5 meters, then the 3 parameters to determine the initial stress state, which are the overburden H, which corresponds to the depth from the surface to the tunnel center, let's say equal to 1000 meters. The specific weight of the rock mass G, let's put an average value of 25 kilonewton per cubic meter, and the factor of lateral side pressure K with a low value, for example 0.2. The last 2 parameters specify a point's position in polar coordinates. For example, the distance r equal to 10 meters from the tunnel center to the point, with the direction of r defined by the angle theta, for instance equal to plus 35 degrees measured counterclockwise from the positive x-axis. The physical units in the input form, that is distances in meters, the specific weight in kilonewton per cubic meter, and stresses in megapascal, cannot be changed. At the point's locations, an infinitesimal element is shown with the stresses acting on the element sides. The infinitesimal element's sides actually represent planes parallel to the element sides. By clicking the command button New Initial Stress, a new initial stress state together with the stresses at the first point's location is generated. This initial stress state is effective until a new one is specified. Numerical values of the initial stress state and those of the actual point are shown in a table below the command buttons. A list with the coordinates and stress values of all selected points can be found beneath the graphical result chart. I click now the command button Initial Stress. There are 3 charts in this sheet. To see all of them, change the Excel zoom factor to 75%. Chart 1 contains the normal radial and tangential stresses SR and ST and the shear stress SRT. These stresses are the results of Kirchhoff's formulas. Chart 2 contains the normal horizontal and vertical stresses Sx and Sy and the shear stress Sxy. These stresses are found using a stress transformation of the radial and tangential stresses to the xy coordinate system. Chart 3 contains the major and minor principal stresses S1 and S2. By definition of principal stresses, no shear stress is acting at the element. As shown in the 3 charts, stresses acting at planes change with the plane's orientations. With the command button New Point Location, a new point's position is defined. The stresses at that new point are calculated with the actual initial stress state. Using new point locations, the tunnel radius A and the parameters for the initial stress cannot be changed. I generate now some points along a horizontal line starting from the tunnel's left side wall. The tangential stress at the tunnel side wall represents the maximum normal stress for this actual initial stress state. It must be checked that this peak stress is less than the uniaxial compressive strength of the rock in order to fulfill the requirement of elastic material behavior within the entire model. Clicking the command buttons Initial Stress and Delete Charts, the Excel charts in all sheets are deleted. Charts in picture format have to be deleted manually. In this prepared sheet, stress points along 2 half circles with radii r of 10 and 20 meters have been selected. The table values beneath the charts can now be used, for example, to plot diagrams for the stresses along the circle as functions of the angle theta. These charts have to be generated manually.